This is Mod 4 Lesson 10, rate of change, which is just another word for slope. Okay, so what we're going to be doing here is we're doing the same thing. We are going to be determining the rate of the change or the slope for graphs of linear equations, okay? Let's start here. Determine the word rate of change. If it's on a slope, it's called the graph of the line. It's called the slope of the line. Rate of change is the slope of the line. Okay. Slope is written as a blank of the vertical change to the horizontal change. It's a ratio of the vertical change, okay, that would be change in y, to the horizontal change, that would be change in x, between any 2 points on the line. Okay, this remains constant for any 2 points on the line. No matter what points you use, you're going to get the same slope. Okay, slope is written as rise over run, or a change in y over change in x. The variable for slope is m. I don't know why they use m, but that's the letter that has been used forever, so that's what we've got to deal with. Now, types of slope, we know we have our positive slope, which means you're going up. That's a positive slope. You have a negative slope, which means the relationship is going down, decreasing. You have a slope of 0, and that would be a horizontal line, or you have an undefined slope, and that would be a vertical line. Now, all we're going to do on this is we're going to find slope. We remember that slope is change in y over change in x, or rise over run. We're going to draw our right triangle, and we're going to determine the slope on each of these. These have points on them. Remember, to do this, you've got to have points that are on the grid lines. So in this case, and here's our y up and down, here's our x left and right. Positive on the y-axis is up, negative is down. Positive on the x-axis is, if you're like you've got a number line in this direction, negative would be this way. So if I'm doing this one, let's see, I'm going up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. This is up 4 and over 5. My slope is 4 over 5. Okay, let's try this one. This is a positive slope because it's going up as you read it left to right. I'm going up 1, 2, 3, 4, 5, 6. So I went up 6, and I go over 1, 2, 3, 6 over 3. Now, if I reduce that by 3 over 3, this would be 2 over 1, right? 2 over 1 is simply 2. Okay, this means that for each 2 I go up, I go over 1. Up 2 over 1. Let's see if these all fit on the line. Up 2 over 1. Yep. Up 2 over 1. See, it works. No matter where your point is, that slope will tell you where each point's going to be, each next point's going to be. Okay. Let's try this one. If I'm looking for the slope here, we know that this is a negative slope. It's going down. Let's look at this. On the y-axis, I'm going down 2. And I'm going in the positive direction, 1, 2, 3, 4, 5, 6. Okay, down 2 and over 6. If you reduce that by 2 over 2, you come away with 1, negative 1 over 3. For each 1 I go down, I go over 1, 2, 3. See, it works. Down 1 and over 1, 2, 3. You can plot your line doing that. Okay, now let's find the slope here. From this point to this point, I'm going down 1, 2, 3, 4, 5, 6, 7. I went down 7. And I went in the positive direction, 1, 2, 3, 4. So down 7 is negative 7 and over 4. I go down 7 and over 4. That's what the slope is on that one. Let's find the slope here. Okay, this is a vertical line. Pick any 2 points. And look, guys, I'm going down 2, and over none. 2 divided by 0. Put that in your calculator, and it will tell you that doesn't exist. There's an error, whatever. It means this slope is undefined. How about this one? I am going up 1, 2, 3, 4. I went up 4 and over 1, 2, 3, 4, 5, 6, 7, 8. Up 4 and over 8. Is that as simple as it gets? No, I can divide that by 4 by 4. That would give me 1 over 2. So essentially it means I go up 1 and over 2. See, that puts you on a grid line. On a point that's on the grid lines. Up 1 and over 2. Yep, same thing. Up 1 and over 2. Oh, right there on the grid line. Still on the line. Up 1 and over 2. Yep, you could continue that if you wanted to. Your slope is 1 over 2. Look at number 7. Okay, on the slope, we're going down 1, 2, 3. Down 3, because remember, our slope is changing y over changing x, which is the same thing as rise over run. I went down 3, and I'm going over 1, 2, 3, 4. Down 3 and over 4. From there to there, I am going up 1, 2, 3, 4. I went up 4. And I'm going over 1, 2, 3, 1, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Up 4 and over 10. If I reduce this, take out 2 over 2, I come away 2 over 5. My slope is up 2, and over 5. 1, 2, 3, 4, 5. Yep, that works. It's on the line. Up 2 and over 1, 2, 3, 4, 5. My slope is 2 over 5. It's going up. Okay. Let's look at number 9. My slope here is going down, so it's going to be negative. I'm going down 1, 2, 1, 2, 3, 4, went down 4, and over 1. Okay. My slope is down 4 over 1. You could actually say that your slope is just simply -4 because anything divided by 1 doesn't change itself. How about the slope here? Horizontal line. Pick 2 points on it. Okay, rise over run. I'm not rising any, so I rise 0. And here I've run 2. 0 divided by 2 is simply 2. My slope is 0. How about this one? We know the slope is negative. It's going down. And in fact, on the y-axis, I'm going down 1, 2, 3, 4, 5. Went down 5. And I go right 1, 2, 3. My slope is -5 over 3. Okay. How about this one? I'm going up 1, 2, 3, 4, 5, 6. So I went up 6 and I'm going over 1, 2, 3, 4. Up 6 over 4. Let's reduce that by 2 over 2. And that gives me 3 over 2. So I'm going up 3. Let's check it and see. Up 3 and over 2. Does that give me a point on the line? Yep. Up 3, 1, 2, 3, and over 2. So the slope is 3 over 2, isn't it? 6 over 4 is the same as 3 over 2. Let's look at this one. To get from this point to this, I'm going up 1, 2, 3, 4, 5, 6, 7. Up 7 and over 1, 1, 2, 3, 4, 5, 6, 7. Up 7 over 7. Okay. If I divide both of those by 7 over 7, I get 1 over 1. 1 over 1 is 1. Let's see if that works. Is my slope 1 over 1? Up 1 over 1. Yep. Hit a grid line. Hit the line. Up 1 over 1. Hit the line. Up 1 over 1. Hit the line. Up 1 over 1. Yep. Hit the line. In each case, I'm hitting it up 1 over 1. See, all these points are on the line. Up 1 over 1. Hit the line. Up 1 and over 1. See, in every case, this is on the line. My slope is simply 1. For each 1 I go up, I go over 1. Okay, this slope is negative because it's going down. Look, I went down 1 to get there. I go over 1, 2, 3, 4, 5. The slope is -1 over 5. I go down 1 for each 5 I go over. Okay, and then the last page on this. Let's find the slopes of these lines. From here, I'm going up 1, 2, 3, 4, 5, and over 1. My slope is 5 over 1. How about from here to here? I go down 1, 2, 3, 4, 5, 6, 7, down 7, and I'm going over 1, 2, 3, 4, 5, 6, 7, 8. Okay, my slope is negative 7 over 8. No way to reduce that, so that's 5. On this one, I'm going down. Let's see, I go down 1, 2, 3, 4. I went down 4 and over 2. Okay, so my slope is negative 4 over 2. I can reduce this by 2 over 2, which gives me negative 2 over 1, which is the same as just negative 2. That means for each 2 I go down 2 over 1. You see, it puts it on the grid line, on the line itself. Down 2 and over 1 puts me right there on the line itself. Okay. Look at number 4. Choose, oh, they put these points way over here. Well, let's see what we're doing. We're going up 1, 2, 3, 4, 5, 6. I went up 6 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up 6 and over 10. So let's reduce that one. This slope, if I reduce that each by 2, I come up way with 3/5. So this one is, the slope is up 3, up 1, 2, 3, and over 1, 2, 3, 4, 5. Yes, that puts it right there. Okay, up 3, 1, 2, 3, and over 1, 2, 3, 4, 5. Perfect. Okay. All right, now let's look at 5 here. If I go down 1, 2, 3, 4, down 4, and over 1, 2, 3, 4, 5, 6, down 4 over 6, down 4 over 6. If I divide both of those by 2, I would have down 2 over 3. Let's see if that works from here. See if that slope works. Down 2 and over 1, 2, 3. Yep, that's on the line. Down 2 and over 3. Yep, it's on the line. Doesn't matter where you check it. It's the same slope no matter where. Choose 2 points on this line. Let's see. How about those 2 points? I'm going up 0 and over 2. 0 divided by 2 will give you 0. Your slope is 0. I go up 0 no matter how many I go across. On this number 7, I'm going up 1, 2, 3, 4, 5, 6, 7, 8. I went up 8. Okay. And I'm going in the right direction, 1, 2, 3. So my slope is 8 over 3. For each 8 I go up, I go over 3. Now I'm going down. Let's count this one. I go down 1, 2, 3, 4, 5, 6, 7, 8. I'm going down 8. And I'm going over 1, 2, 3, 4, 5, 6. Down 8 and over 6. Okay, let's divide that by 2 over 2. So we can simplify it. I've got negative 4 over 3. Is that the slope? Go down 1, 2, 3, 4, and then over 1, 2, 3. Yeah, it puts it right there on the line. Those two have a slope of negative 4 over 3. Down 1, let's see, down 1, 2, 3, 4, and then over 3. 1, 2, 3. Yep, the line, see, has a slope of negative 4 over 3. How about this one? I'm going down 1 and over 1, 2, 3, 4, 5, 6. Down 1 and over 6. Okay. And on this one, I'm going down 1, 2, 3, down 3 and over 1, 2, 3, over 3, down 1 and over, down 3 and over 3. If I reduce that by 3 over 3, I have down 1 over 1, which is simply a slope of negative 1. Down 1 over 1. Down 1 over 1. See, all these are on the line. down 1 over 1. That's the slope of it, no matter where you check it. How about this line here? Let's pick 2 points. Okay. My rise is 2. In this case, I've gone up 2. My run is 0. You put that in your calculator, it will tell you you cannot divide by 0. So this is undefined. And then this last one here, to get from that point to that, I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going over 1, 2, 3. This is 9 over 3. My slope is 9 over 3. If I divide both of those by 3, I get my slope is 3 over 1. So my slope is 3. Okay. That means for each point, it'd be up 3, up 1, 2, 3, and over 1. Yep. Up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. Okay. The slope is 3 no matter where I check it. This is just some more practice on how to find slope from using rise over run method.